actually turn things over to Ken Levinson from the Passive House Network, who is going to give an introduction to our speaker tonight, John Mitchell. So Ken, take it away.
Great, thank you, Aaron. Great to see everybody here, great to be here. For those who don't know, I'm the executive director of the Passive House Network and longtime Passive House advocate. And we're really excited about having the conference coming to Boston, to Massachusetts and New England in June. It is a hotbed of Passive House and has led the nation in many ways from the beginning. So we're excited to showcase a whole lot of what's happening in the area, as well as stitch in stuff that's happening across the country and from around the world. And looking forward to those conversations. We're really thrilled to be able to partner with Passive House Massachusetts. And it's been nice over these last couple of years sporadically to join these meetings with Passive House Massachusetts and to get to know more and more people, and hoping that this event, the conference, is going to be a great catalyst for more conversations and communication. The conference, as you see, is really focused on these 4 ideas of efficiency, electrification, embodied carbon emissions, and social equity, and really the intersections of all of those things, and finding new ways to leverage and step out and be really super ambitious as we need to be in these times of crises, multiple crises. So there is a discount for Passive House Massachusetts members. And I just want to drop, I was going to drop the discount code into the chat. Is that okay? Scout's honor. Let's see, everyone in the meeting. I was going to drop in the link to the chat, to the event website. They're kind of run on there. Maybe I should have done that separately, as well as that conference overview. With that, you can go into the detail of the conference sessions on the conference website, as well as seeing the speakers and so forth. So I'm sure you'll see plenty more about all of that as we go forward in the next 4 weeks, and hope to see and meet many of you there. So it's my great pleasure, when Aaron mentioned that this year is about retrofits, much the way Net Zero was last year, really excited to put out the offer to do a session on EnerPHit. It is a standard that's 12 years old since it was introduced. There's been a lot of activity around it. And I knew somebody really good who could give the presentation. John Mitchell from Building Type Consultants. And if you aren't familiar with Building Type, I ask that you get familiar with them. They're one of the driving firms of Passive House in America, and there are many shining lights in the Passive House world. There's no doubt about it. But they are one of them, and they consult on all sorts of high performance Passive House buildings, certifying in both PHI and PHMass systems. They're really, John and his partner Ed May have kind of set the standard in many ways, and we feel lucky. I'm based in Brooklyn, New York, and Building Type is in Brooklyn, and we've been really lucky to have them on this journey. So I'm going to give a quick intro here to John himself, and then we'll be on our way. Hope this won't be too painful, John. John Mitchell graduated with a Bachelor of Arts from Colorado College in 1996 and a master's from Parsons New School in 2009. In the interim, John worked as a carpenter, first on residential renovations and later design and construction of custom homes, and as a project manager and digital fabrication specialist for a theatrical design and production company. I did not know that. The combination of design and craft embodied in Passive House resonated with him when he was first exposed to Passive House as a construction manager for Parsons, the New School, Stevens Institute of Technologies, and Stevens Institute of Technologies 2011 Solar Decathlon entry, which in this blurb, it doesn't mention that they actually won the Solar Decathlon that year.
Not that year, but eventually.
Oh, you didn't win it in 2011. Sorry. You did win it later. Fantastic. He soon became a certified Passive House designer and became training others. He worked as a longtime trainer, and this is the other great strength of John and the firm, trainer for Passive House Academy, and has been a longtime trainer for us at the Passive House Network. And if you have a chance to attend a training of him, I recommend you go for it. So with that, without further ado, John, take it away.
Wow, thank you, Ken. That was really nice. And thank you, Aaron and Passive House Massachusetts for having me today. I'm really excited to be with you guys. And I hope this is interesting for you. I'm going to assume that we have some familiarity with Passive House things in general, and assume that we know that there's this thing called PHI and there's this thing called PHIUS. And I'm going to dive pretty much into the EnerPHit standard, which is PHI's standard for renovations. And it might get a little bit nerdy, and there might be like a tiny bit of math, but like you're not going to have to do any of it. So I hope not to lose anyone, but I do want to point out the important aspects of EnerPHit, and some of them are quite technical. And so I just want to bring those things to the fore, and we can chat about them and get to sort of understand the standard better as we move along. So ask questions in the chat, or if you'd rather wait till the end, that's fine too. And I will share my screen and we'll jump in. Okay, do you have me? Great, awesome. So eventually, I'm going to talk to you about these two renovation projects that we have been working on. One is a certified retrofit EnerPHit project that was a historic masonry building, so it was insulated from the interior. And the other is a wood-framed exterior insulation renovation, so the much vaunted chainsaw retrofit. And that one hasn't actually been certified yet. It's still in process, but we do have details to share, and we can sort of talk about those examples. So that's what we'll sort of end on, is those examples. I also want to just make sure that we also understand that that EnerPHit projects don't have to look like single-family homes. These are EnerPHit projects as well. The Pirelli building, or the Armstrong Rubber building, or the Marcel Hotel now on the left-hand side there, that's if you've ever driven past the IKEA on I-95 near New Haven, you've seen this building and maybe wondered what it is. But it's a brutalist masterpiece from Marcel Breuer, and it's being renovated to the EnerPHit standard currently. And then we have the Ken Sobel Tower in Hamilton, Ontario, which is a really impressive multi-storied residential building that's been renovated to the EnerPHit standard, and that one's done and occupied. So it's not just a single-family homes. It's really just anything you are going to renovate, you can renovate to the EnerPHit standard, and we would encourage you to take on some of these more challenging building typologies, because Lord knows we need them. So yeah, so I'm going to assume that you know about Passive House, that you know that we have these 5 principles, that we're going to super insulate our buildings. We're going to have continuous layers of insulation. We're going to really emphasize air tightness. We're going to design our buildings such that they're thermal bridge free. We're going to really, focus on high quality window components and installing them correctly, and siting them correctly, and shading them appropriately. And we're going to have mechanical ventilations with high levels of heat recovery. Those things we know, right? We're Passive House people, we get that. And we know that the buildings that we build are going to result in projects with very low operational energy. They're going to have really awesome occupant comfort. Air quality is going to be great. They're going to be really durable buildings that will last a long time because there's very low moisture risk. And if the power goes out, we're good, because those buildings are going to coast through those power outages because they are resilient, they are thermally constant, and they are going to do a good job of keeping us comfortable, even when things outside are not so great and conditions are not perfect. So that's a Passive House, right? And we know that for the Passive House standard, the International Passive House standard, we have certain criteria. We're going to look at the annual heating demand specifically, and the annual cooling demand specifically. Those targets are 4.75 kBTUs per square foot year. Just to remind you, if you already knew that, and to bring it up if you didn't. And we're going to also focus on airtightness. So the building airtightness is going to be measured at 0.6 air changes per hour at 50 pascals. That's our certification criteria for a passive house building is airtightness. And then we'll also look at the total energy of the building and make sure that our building falls under the total primary energy or source energy targets for passive house. That's a passive house building. That sounds awesome. Why don't we renovate our buildings to the passive house standard? Well, it's kind of hard. There are going to be things that are going to get in our way. We didn't put this building where it is today. Somebody else decided where it's going to be. Somebody else decided where the windows are. Somebody else decided what the structural system is. And we're going to inherit all of those decisions. And those decisions weren't necessarily made with our well-being in mind as passive house consultants and designers. Those decisions were made with 1980s thinking or 1880s thinking or 1780s thinking, depending on the building that you're inheriting. So it's not going to be really ready for us to make it a passive house. There's going to be things that are in our way. And some of that might have to do with how the building is oriented. It may be facing due east with a ton of glass. It may be, who knows? It may have tiny little windows that don't get any solar gain at all. You may have real challenges with air sealing that building because of the way it's put together. You may have real challenges with thermal bridging because of that way that building is put together. If you look at the example on the right there, that detail, we have a masonry wall, or we have a concrete wall, and we have a concrete floor slab, and we're going to try to renovate that and do a good job of insulating that detail. We're going to put some insulation on the outside of the building where it belongs. We're going to put some insulation at the slab level where we want it. And what happens? Those insulation layers don't meet because we can't get to the detail. We're going to have thermal bridging that we just can't avoid. So what do? We're going to try to get to the passive house standard, and we might not be able to get there because of all of these things. So the EnerPHit standard is an acknowledgement of these challenges. The EnerPHit standard says, yes, you're going to do your best to get to the passive house standard, and you may not quite get there. So what we're going to do is we're going to relax just a little bit, and I mean just a little bit. It is really not very much. The criteria for passive house certification in order to help you get over the hump, because we want you to do the best building you can. We want you to make these high quality renovations, but we're realists. We're going to understand that there's going to be some things that are going to be a little bit of a compromise on a renovation because you just don't have control over all those things. Those things that are going to be a little bit of compromise are mostly going to be about air tightness and thermal bridging. We can do a pretty good job at insulating these buildings. We can buy and install high performance windows, and we can do mechanical ventilation with high levels of heat recovery. That's not a big deal. It's really about the air tightness and the thermal bridging where things are going to be a little bit of a challenge. So in 2010, as Ken mentioned, Passive House Institute came up with the EnerPHit standard in an acknowledgement of these challenges. And they gave us not one, but two certification pathways. So this actually makes it a little bit more confusing than it needs to be, but it's actually quite helpful. The first certification pathway is the EnerPHit by energy demand method. And you could think of this as like passive house in sweatpants. It's a little bit relaxed from the full passive house certification criteria, but it's effectively the same. So instead of having a heating demand target of 4.75 kBTUs per square foot year, we're going to have a little bit more than that. And then instead of having an air tightness requirement of 0.6 air changes per hour at 50 pascals, we're going to have a little bit more than that. And then that's it. Effectively, it's the same as the passive house standard certification, except for those two minor adjustments. The other pathway is what's known as the EnerPHit by building component method. And this is a wholly different beast. This is actually a prescriptive version of passive house, which we don't really see very much. Passive house is essentially a performance-based standard, but the EnerPHit by building component method for EnerPHit renovations is actually a prescriptive standard, and it's based on your climate zone. You'll have certain minimum R values that you need to achieve for the various components of the building. So for below grade walls, for above grade walls, certain maximum U values for your windows and doors, and a certain minimum performance for the ventilation system as a whole. So those are the two separate pathways, and you might want to evaluate your project looking at both of those and sort of decide which one makes the most sense. Regardless of which of those pathways you choose, we'll have the same air tightness requirement of 1 air change per hour at 50 pascals. Moisture management is going to be carefully assessed, meaning that we're going to look at all of our details really carefully and make sure they're doing what we expect it to. The primary or source energy targets are tight. They're a little bit relaxed from the full passive house standard, but they're still quite tight. And window thermal comfort requirements of the full passive house certification standard are enforced. And that's an important thing that we'll want to talk about a little bit more in just a couple of seconds. So 2 pathways, many aspects of those pathways are the same, but there's two important differences, one being that one is a performance-based standard, just a slight relaxation of the full passive house certification. The other is a prescriptive standard. So regardless, we're going to be at 1 air change per hour instead of 0.6, and we're going to adjust the primary energy or the source energy target slightly to take into account that we have a little bit extra heating demand. Okay, so let's look at the requirements that are common to both of the approaches. So first of all, air tightness. And again, when we say it's a relaxation from the passive house standard, we're talking about 1 air change per hour instead of 0.6. And we know that in the United States, people who are actually enforcing the building code are maybe enforcing a building code air tightness requirement of 3 air changes per hour, if they're actually enforcing an air tightness requirement in the building code. So this is still a very rigorous air tightness requirement. That'll be tested according to EN 13829. So that's a multi-point blower door test at both positive and negative pressures. So we're going to test the building at 20 pascals, 30, 40, 50, 60, 70 pascals at both blowing in and blowing out of the building. And we're going to average the results and equate them to 50 pascals of pressure. That will be our certification blower door test. So still quite rigorous. The other thing that we will be keeping an eye on is the durability of the building. We want to make sure that as we're insulating this building, we're still providing a really robust building envelope with very high surface temperatures. And so we'll be looking at our details and assessing what's known as the temperature factor. And this is the math part that I don't want anybody to get very scared by. I know it's late in the day, but this is actually quite simple. The temperature factor is calculated by taking the temperature of a surface minus the outdoor temperature over the indoor temperature minus the outdoor temperature. So delta T on the bottom and delta T from the surface to the outside on the top. And that gives us a unitless ratio really of the delta T from inside to outside. And it gives us an indication of how resistant that detail is to moisture. So if we have, and you can see on the right-hand side here, there's some climate zone specific recommendations for the minimum FRSI factor that we need for our details. So if you're in Massachusetts, you probably will be targeting this cool temperate climate number of 0.7. What does that really mean? Well, when we look at our details, we're going to be assessing them both for the thermal bridging. So that's on the left-hand side here, that detail we're calculating the psi value. So the additional heat loss that happens where the 2 wall types meet in this detail. But we'll also be simultaneously calculating the FRSI, that temperature factor, and be checking to make sure that at the interior surface of those assemblies, we have really high surface temperatures. And in this case, you see the temperature factors are 0.85, 0.88. Those are good, those are really high. We have warm temperatures on the interior surfaces there. We have very low risk of mold and moisture damage. So this is not to say that you'll have to calculate every single detail in your project, but as you're working with your certifier, they may identify certain details and they'll say, hey, we're not sure about this one. Could you do this calculation? And this is what you would do. You would prove that you have high surface temperatures at each of the interior locations on these details. Another important element is the window thermal comfort requirements that are part of the PHI's passive house standard. So these are specific to PHI. And quite different if you're used to working in projects in PHIAS than those PHIAS projects. So it's important to sort of zoom in on these real quick. We know that windows can be a problem for occupant comfort, right? We know that those cold surface temperatures in the wintertime can really make us feel cold. They can steal our body heat, but we'll be radiating heat towards those cold surfaces, and we'll be made to feel uncomfortable by them. And historically, we've taken care of that by putting heat sources under the windows. Put our radiators there, as you can see behind me. But we want to manage these things passively, not actively. So we want the window itself to provide excellent thermal comfort. And the PHI thresholds for thermal comfort are quite rigorous. They're more conservative than what you might be used to. They're more conservative than the ones that are in the standards that are referenced by PHI. And the reason for this is because these thermal comfort thresholds are a proxy for a whole bunch of other different things. So it's not just about the way that surface is making me feel because of radiative asymmetry, temperature asymmetry between myself and that window. It's also about the stratification that occurs in the room because of low performing windows, and convective looping that can happen as a result of low performing windows. So this comfort criteria, this comfort threshold built into the PHI standard, is taking all that and kind of condensing it into one thing. And it's addressing all of those things with this one test where we test the performance of the window. And so it could be quite a challenge. And just to put up the most boring slide ever, the PHI window comfort criteria will determine window performance. This is what's going to drive the window performance of your EnerPHit project, also your PHI certified project, but specifically in this case, your EnerPHit project. The limiting threshold is 7.6 degrees Fahrenheit difference between the operative temperature in the room and that window surface on the coldest 12-hour period that your building is going to see. That's pretty rigorous, right? So for Boston, we're looking at 1 degree Fahrenheit outside, 68 degrees inside, and that window has to be less than 7.6 degrees colder than the room. So that window has to be somewhere around 61 degrees Fahrenheit. Passively, just by itself. That's a very high performing window. It takes into account not just the window itself, but also the way the window is put into the building, which makes this a little bit even bigger challenge for renovations, because in renovations, we don't have as much control as we might like over our window installation details. So the U value of the window that's required to meet the comfort criteria, which you can see in this table on the upper left, is a combination of the performance of the glass, the performance of the frame, the performance of the spacer that holds the glass panes together or apart, and the way that all of that is put into the wall. So all of that gets combined into the total U value of the window as it's installed in the building. And that's what we evaluate this comfort criteria on, is the U value of the window as it's installed. So not only do we have to buy good windows, we have to detail them correctly so that we don't lose the performance of the window in our installation thermal bridging. So all of this will get checked to the PHPP. We don't actually have to do the math and calculate whether or not our window is meeting the certification criteria with a pencil and paper. We will just plug the windows into the energy model, and the energy model will hopefully come up with a column of no red check marks. This one came up with some red check marks. And you can see here, this is a PHPP for a project based in Boston, Massachusetts. The outside temperature, the design temperature for the window comfort criteria is 1 degree Fahrenheit. The recommendation for a U value of the window installed to meet that comfort criteria is a U value of 0.14. So a really good window installed really well. So this window, we would take a look at the detailing. We could see if we can improve the detailing. If not, we would see if we can go back to the manufacturer and improve the performance spec. If we can't do that, what do we do? Well, there is fine print. There are exceptions. We have things at our disposal. We can actually go back and add heat to that window. We can deliver heat at the perimeter of the building. That thing that we're sort of avoiding doing mostly in Passive House because we don't have to, we can do in this case to overcome the relatively poor performance of a few windows, doors in the project. So we can go old school. We can install a radiator underneath that poorly performing window. or we can go slightly newer school and put some electric heat mat underneath a poorly performing door like we've done here. This will get you over that requirement for passively managing the thermal comfort of the window. So you're actively now managing it by adding heat at the perimeter of the building. So on renovation projects like that Pirelli building that we saw earlier, I think that's what's happening. That they aren't able to get the windows spec that they would need to meet the comfort criteria. And so instead they deliver heat at the perimeter of the building. Okay, so those are the things that were common to both certification pathways, the EnerPHit by energy demand and the EnerPHit by building component method. So let's look specifically now at this EnerPHit by demand certification is about. So it's a climate zone specific threshold for the annual heating demand that adjusts as we get farther north, because it'll be harder to hit your targets as we go farther north. So for the warm climate zone, no adjustment at all. Warm temperate, where I am in Brooklyn, New York, 6.34 kBTUs per square foot year. For the cool temperate, 7.92. And as we go to cold and Arctic climates, it gets even higher. So in most of Massachusetts, you'll have a cap on your annual heating demand of 7.92 kBTUs per square foot year. Cooling is equal to the passive house requirement, so 4.75 kBTUs per square foot year, plus a little bit of additional for dehumidification, if you have a dehumidification requirement in your region. Otherwise, this is really just passive house, a little relaxed. The EnerPHit by building component method, again, so this is that second pathway, the prescriptive version of passive house. The table's more complicated, everything's a little bit more complicated. So again, it's climate zone specific, but we have separate requirements for different components of the building. So going from left to right, there's the ground, which is calculated on a per project basis. The exterior insulation of the building, depending on your climate zone, starts at, let's see, for the warm climate, 11.36. So an R value of 11.36 for your exterior building components. And if we go all the way up to the Arctic region, we need an R63 for all of our exterior building components that are exposed to the ambient air. However, let's just zoom in on your climate zone. You see that the exterior insulation climate for the cool temperate climate is roughly an R38. So that's a combination of all of your floors and roofs. I'm sorry, your walls and roofs that are exposed to ambient conditions. However, if you insulate that building from the interior, so like we do with many historic buildings, masonry retrofits and things like that, your R value requirement is 16.2. So you only have to hit an R 16.2 sum of all the R values, average of all the R values in your project in order to meet the certification criteria for the EnerPHit by building component in the cool temperate climate. That's not that bad. That's not that hard. We do that with masonry retrofits all the time. You can see there's an overall U value requirement. So it differs depending on the orientation of the window, but for your vertical typical window, it's 0.15. And then you see on the far right there, a requirement for your ventilation system efficiency has to be at least 75% efficient. Okay, that's not just the box that you buy though. So that 75% efficiency takes into account the ERV, the ventilation component, the HRV or ERV, plus the losses that are associated with the ductwork from that unit. So if you have like an 85% efficient unit and then you throw like 150 feet of ductwork on it from between the unit and the outside, the total efficiency of that unit will go way down. It also takes into account things like range hoods, exhausting dryers, or other exhaust-only ventilation sources. So that 75% is a total building ventilation system efficiency, which can be very challenging to hit if you have more than a couple of exhaust-only sources. So something to be really careful about and to be aware of, this is the thing that makes the EnerPHit by building component a little bit challenging. is to really hit this total ventilation system efficiency criteria of 75% or greater. We start with ERVs. ERVs are already a little less efficient than HRVs, but they're the right thing to do in most of the climates that we work in. So maybe the unit is like 82 or 83% efficient, something like that. And then it's a renovation, so you can't necessarily put it where you want. So you end up having some ductwork between the unit and going to the outdoors. So that'll cut down on the efficiency. And then we want to ventilate the buildings properly. We want to exhaust air from the kitchens. So that's going to cut down on your efficiency. And pretty soon you're below that 75% threshold, and there's not much to do. So something to flag early in your renovation projects is this total ventilation system efficiency. Now, again, for this certification, there is fine print, particularly if you're working on historic buildings. There are exceptions. And if your Heritage Council, your Landmarks Commission, whoever it is that has things to say about the exterior of your buildings says you can't replace these windows, that doesn't mean you can't necessarily do an EnerPHit renovation. You can get an exception for these things. PHI will push hard on these things. They'll want you to really do the best that you possibly can, and to push whoever's asking you not to do the thing, to do the thing. But there are exceptions available to you. So so take a look in the guidebooks for this fine print that will help you. As with other passive house projects, the EnerPHit projects are eligible for what are known as the advanced certification classes. So we have on the left-hand side this sort of passive house classic building, and then as we become more efficient and add more renewables to the building, we have available to us these advanced certification classes. So we have a passive house plus and a passive house premium, and PHI will never put these in terms of net zero, but somewhere between passive house plus and passive house premium is what we think of as a net zero building. Another thing that's really amazing about the EnerPHit program, I think, and it's very useful, particularly for larger projects, if you're managing a building portfolio, or if you're managing a larger property, and you do this thing where you plan out when you're going to replace things, where when your roof is going to need replacing, when your windows are going to need replacing. You can do what's known as a step-by-step retrofit. And it's something that's sort of codified within the EnerPHit protocol. And you can plan out your retrofit, and it could be a 30-year project. And you could say, in year one, I'm going to replace the roof because I have to. The roof is falling off. And so I'm going to replace that, but I know that I can't do anything else for then 5 more years because I don't have any money, and my windows have 5 more years on them. And you could plan out a renovation over a long period of time, build it in the energy model, build the PHBP for it, and sort of show your work, show how you're going to eventually get to a full EnerPHit project. Register that project with PHI, and then after you've completed 20% of that work, you can get a letter of pre-certification. It says, hey, you're on track. You've shown us that you intend to get this to full EnerPHit certification, and we'll give you, a document that says that you're doing the right thing and that you're on track to hit your goals. And then you could just implement those changes as time and money permit over a long period of time. And so at the end of 20 years, you could have an EnerPHit building without doing a full gut renovation. So I think that's a very useful thing. I don't think enough people really avail themselves of this opportunity to really chart out a renovation project over a long period of time and use this tool. But it's the tools are there, and PHI is happy to help you with that. Okay, so let's look at a couple of examples. I'm not going to dive into too much detail, but let's start with a masonry retrofit. This is a row house here in Brooklyn, New York. It was built in the 1840s, we think. It's in a landmark district, and the existing conditions not so great. So it's a valuable building because of its location. It's a really neat building because of when it was built. It was just kind of a sad building because of its condition. So it needed lots of work and lots of love. But that's the great thing about doing a full renovation like this, is we can give a building the attention that it really deserves. This once every 150 years in this case, or 170 years, opportunity to really peel it back to its bones and build it back up and bring it up and ready for the next 100 years. So the strategy here was to do an interior renovation. So we did, it's a landmark building, as I mentioned, so we weren't going to touch the front facade. And in fact, on this one, the landmarks didn't want us to do much on the rear facade either. There were some extensions that were allowed on lower levels, but the masonry walls that were rebuilt had to be rebuilt as regular 3-wide brick walls, which is pretty uncommon. So we took the same approach on all of the interior walls, is to do interior insulation. So first we start with air sealing at the masonry surface after we've done repair, then insulation, then the air tightness on the front and rear, and then a service cavity for running electricals and things like that. Details you may have seen before for historic masonry retrofits. We also did ventilation, ERVs, dedicated ERV separate from heating and cooling system, as well as kitchen ventilation, so extract air ventilation with the kitchen hood. And then the HVAC was shifted from a heating boiler and oil-fired a boiler for heating and hot water to heat pumps for heating, cooling, and domestic hot water. First thing we have to do is fix the building, right? So we tear everything out, and you can see that things are just not in very good shape. You have the front and rear walls somewhat miraculously are not connected to the rest of the building. They're just standing there. And there's a full gap. You can sort of put your hand in the crack between the party walls and the front and rear walls. So that needs to get fixed. And lots of brick that's deteriorated over time. Things need pointing, things need to be brought up to today's standard. After pointing, they did a parge coat over the masonry so that everything was kind of smooth, and could take then a fluid applied weather barrier that we apply to the interior that acts as the airtight layer over that masonry surface. And you can see on the right hand side, that's the structural engineer helping us to hold those front and rear walls up and connect those front and rear walls to the party walls where they were not connected before. And then the fine air sealing that the team has done there around those steel brackets. So from the bottom up, going left to right, the air tightness layer is the subslab vapor barrier that comes up the walls, 4 feet or so in this case, and then transitions to a fluid applied air barrier vapor retarder on the walls. And then at the roof, not the best picture on the right hand side, we transition to a plywood on the underneath side of the roof as the airtight layer there. And again, windows, windows, windows. That's really an important thing in all of our EnerPHit projects. And it's a hard thing to do well particularly in historic masonry projects, because we have to push the window out. It has to be where it was before, which was sort of out to the front of the masonry layer, which is not continuous with the insulation layer that we've installed on the inside of the building. So we have to bring those two things together. We have to make space around the window installation for insulation so that we can connect the window to the insulation layer and to have as low thermal bridging as we possibly can. So we get as much out of those windows as we can, and we meet that comfort criteria. So on the sides, we're seeing a jam detail here. It's not so hard at the sides because we had weight pockets there that used to house the window weights that would hold the windows up, the double hung sash windows. And so when we remove that, we expose those window pockets, and those are great places for insulation. At the head and the sill, it's not always that easy, and sometimes we have to actually move a lintel up at the head and move some brick down at the sill in order to connect the insulation layer to the window. In the end, it looks amazing. It's a beautiful brick row house ready for the next 100 years. And then the other one I want to just show you real quick, and we can then have a little discussion after. This is a historic wood frame building built in the early 1900s. This is in northern New Jersey. So it's at climate zone 5A. And this is sort of the opposite approach. Instead of an interior insulation strategy, this is a fully exterior insulation strategy. And we have this excellent client who is just like, he's an engineer and he's super up for it. And he's gave us this wonderful documentation at the beginning, telling us exactly what he was looking for in a building. He's like, and he said he wants, he's saying all the right things. It's almost like he'd done his research. He's looking for improved indoor air quality, excellent thermal comfort. He's looking for low heating energy demand, and he wants to retain the charm of his 107-year-old building. So these are really great things. And then he sent us screenshots from his fuel bill. And his home is the one there in the middle that is towering above the others. He's using a ton of energy to heat his big 4-square building, and he would like that to change. And he wants to crush that little greenhouse on the right-hand side. That's his goal. So the strategy here is to take the exterior finish off, cut the eaves off, take the detail off the exterior of the house, install a weather resistant barrier / air barrier on the exterior sheathing, then add insulation, and then put all that nice detail back. We're going to add, again, dedicated mechanical ventilation with heat recovery and range exhaust, and we're going to switch from his gas boiler to a heat pump system for both heating and cooling and domestic hot water. The assemblies look like this. So we were able to actually remove the existing floor in the basement, which is not always possible, but we got to in this case. So we were able to put some insulation under that floor before pouring a new concrete slab. We're able to get to the foundation walls all around the building. So we're going to do both interior and exterior insulation on the foundation walls. The above grade wall is the existing 2x wall with insulation plus 4 inches of exterior insulation, which was originally spec'd as wood fiber, and it was not available either maybe in time or maybe for the right price. And so we're moving to the mineral wool and then a vented rain screen. And then at the roof, again, the existing roof framing plus 5.5 inches of exterior insulation, mineral wool in this case, and then a vented assembly is there as well. So for the windows, we're extending out the existing window bucks by installing a plywood surround, pushing the window out towards the continuous exterior insulation layer. And again, we're always looking at those surface temperatures on the interior and trying to get as high performing a window detail as we possibly can. So it's about 3,800 square feet of building. Total heating load is about 23,000 BTUs per hour. I asked the client what his current boiler is rated for. It's rated for 122,000 BTUs per hour. So I'm not sure that was sized correctly, but we're going from 122,000 BTUs per hour of capacity to 24,000 BTUs per hour of capacity. That's cool. So in our EnerPHit projects, we get almost all the stuff. We get excellent occupant comfort. We get really good indoor air quality. We get durable, low moisture risk assemblies. We get good resiliency. We get low operational energy. We just don't get as low operational energy as if we had a full passive house building. It just performs a little bit less well. And the graph on the right shows one of our projects. We typically try to show clients what it takes to go from code minimum to EnerPHit to passive house. And we will, show them what assemblies would get them there and all the measures that they'd have to take to get here. But you can see in terms of the total heating and cooling energy demand, the difference between the EnerPHit by component version and the EnerPHit by demand version, it's a little bit. That EnerPHit by demand version is a little bit more rigorous. And then it's a little bit more rigorous still to get to full passive house. So it's not a huge penalty. It's just we're gonna pay a little bit more for energy. But in the meantime, we've got really excellent building. It's going to last for a very long time and deliver really, really good occupant comfort. So I'll put these links somewhere more useful than in this slide, but most of this information is available to you in the PHI's building standard document, which is a merciful 26 pages. It's really not a huge document, and it covers both full passive house certification as well as EnerPHit certification. It gives you the full guidelines there. So I'd point you to that, and then there's a couple more articles that are quite interesting and useful. But I will maybe I'll put those in the chat once we're on to discussion. And I'll let Ken jump in and talk a little bit more about just remind us again about the conference, and then we'll take questions.
Thank you, John. I don't have really anything to add other than to say there are a couple of great retrofit sessions at the conference, and one in particular is on a 20-story. Well, John is going to be in a great one as well.
Thank you.
But this other one I'm thinking about is 20-story occupied building retrofit for affordable housing in Ontario that's just finishing the third of 3 phases of EnerPHit retrofit. Super interesting, lots of lessons learned, and they are really going for the Holy Grail in terms of pulling it off. So that should be super interesting, as well as a lot of other great content. So yeah, I hope we have a nice discussion here. Thank you, John.
Be there.
I always learn something.
Good.
Yeah, thank you, John. That was an excellent presentation, a good overview of the EnerPHit program, and I enjoyed seeing the 2 case studies presented there briefly. We're going to turn it over to questions and discussion. So folks can either use the chat room if you want to ask questions there, and we can read them out, or you can use the raise hand feature here available in your menu options here on Zoom in order to ask a question directly. We can unmute you. So we have a question already in the chat room, John, here. Do you add a passive house window? Have you ever added a passive house window on the inside, leaving the historic window on the outside? So just sort of putting a new window on the inside.
I haven't in any projects, but it's certainly been done. There's precedent for it. So yeah, that's definitely a possible approach.
Right. Let's see. And how are you attaching the windows in the brick building detail that you showed?
Let me pull that back up. Okay. I'll get there. Oops, sorry. Okay. So you might be able to see there's a plywood layer that's attached to the wood stud. So I probably should have described this in more detail. We have a wood framed wall held off the masonry wall by whatever amount we determined, an inch at least. So the the blown-in cellulose that we'll use to insulate that space will be able to sort of fill in behind this stuff. We find that anything less than an inch, and it's just not enough to fill that space. And we want that continuous insulation layer between the masonry and the wood frame wall. So that's held off an inch, and then a 2x4 wall. You can see that 2x4 on the right-hand side there has a piece of plywood attached to that, and that extends into the window opening. And at the outside with brick, you might have a block every 12 inches or something like that to attach that plywood to. So it looks like it's just floating there, but we just haven't drawn like a discontinuous block. And then the window itself is attached to that plywood layer. That makes sense.
Yeah, I think that does make sense. Transitioning a little bit away from windows here, we had a question about the cost of that New Jersey house renovation. If you have any idea offhand of the cost of that project.
Too much is the feedback that we've gotten so far, but that's always the feedback that we get in the first round of pricing. I don't know what it's supposed to be, but it's certainly too much. I don't have hard numbers yet, so and it's not something we're usually privy to. But I think it's the owner is committed to sort of going above and beyond here. It's not for the faint of heart, I would say.
Which I understand, and to give folks maybe just a way to think about it, what in your experience has been the largest cost drivers for past house renovations, just in a project like that in an old wood house?
Well, I think in this one, it's really the exterior approach. It's the labor that's involved in taking down the existing finish and building back in a thick insulation layer. And right now it's just, insulation's expensive. Maybe insulation has always been expensive, but it's particularly expensive right now. And so, it's difficult to get it into the project. It's a long time horizon to pay it back. It's just the way it is. Like we're doing this for a long-term investment, but it's pretty long.
All right, we have a few more questions here in the chat room. And again, folks, if you want to ask a question directly, use the raise hand feature and I'll get to you. We have a question here about the ducting that you use for the heat pumps. If you could just talk a little bit about how that worked and how it was installed.
So in both of the projects, this is just sheet metal duct work. Nothing terribly fancy, I don't think. That's in the row house renovations, it always ends up being complex because there's always a desire to maximize livable space and minimize mechanicals, and even though the mechanicals really do need some room, and so they end up being sort of shoehorned into tight ceiling cavities and then ducted around in maybe not the most optimal way. But we work with some really great mechanical engineers who are really good at keeping an eye on things and making sure these things get run correctly so that we don't have just tremendous amount of static loss in the pressure loss in the ductwork.
Great. I'm going to get to all the questions here in the chat room, but I'm going to skip a little bit to one relevant to the last question about the exterior, well, how you mentioned the exterior insulation being a large cost driver. So have you ever done a successful retrofit without removing these external eaves and external details? Not doing the so-called chainsaw retrofit that you mentioned.
From the outside, but not taking it all down. Is that the question?
Well, it doesn't specify from the outside. I guess you mentioned the brick building doing it from the inside. On a more of a wood frame building like the one that you were showing. Have you done that from the inside and not removing all the exterior details?
We haven't, but that's mostly because of where we live. I mean, most of our renovation projects are these masonry buildings, and that's just because of where most of our work is located. And when we do, we've had a few opportunities to do projects that are more single family homes out of the city, but we haven't done a wood frame from the interior. It's possible, but we just haven't done it.
Right. And someone's asking about the vapor control methods that you're using on the Mason area retrofits.
Mm-hmm. So I think I mentioned, but I'll just go back and double check. So we install first a vapor variable layer, airtight layer on the masonry. So that could be something like Viscon for Proclima. There's a bunch of other blower door proof is another product that another manufacturer makes, or it could be something like one of the base layers for a EVE system, like a Stowe Gold or Stowe Emerald, something like that. So one of those elastomeric, or one of those coatings that gets applied to masonry surfaces and has air tightness, but also either vapor variability, like the Proclima system does, or vapor openness, because we want to ensure that masonry wall still has an ability to dry in if it needs to. And then on the interior, so because we've put that on the masonry retrofit, because we put that airtight layer in the wrong place, it's on the outside of the insulation. We also need to provide vapor control. So we install a membrane at the interior side of the wood framing, and air seal that layer as well. And that gets connected to the party walls and then connected to the windows and doors. All buttoned up.
Excellent. I'll get back to some of these chat room questions, but I do want to let some of the folks with their hands raised get in on this discussion. So Hank, why don't you go first?
Can you hear me?
Yes.
Yes.
So one of the classic questions that comes up with masonry buildings where you insulate from the inside is, what have you done to the vulnerability of the 3-weight, 2-weight brick wall on the outside that doesn't get any of the residual heat loss to keep it from freezing and thawing?
Mm-hmm.
Where do you actually solve that problem in your detail?
Well, we solve it first from the outside. So we want to make sure, and we're very fortunate on a lot of these buildings to have really like great cornices and good water management, bulk water management from the exterior. And if that's not there, we want to put it back. Or, it's usually been taken away. Somebody thought they were making the building look cool by like cutting the big cornice off the front of the building, or taking, these overhangy bits away. But what that does is expose that building to vulnerability from bulk water. So we want to really shed that water on the exterior as much as we possibly can. And then we're trying to manage the assembly such that we're not like really going over the top with insulation. So we still have some energy moving through that wall. It doesn't necessarily mean it's going to be above freezing for the entire year. But if we're staying within an R20 or so, and where we are, then we're still allowing some heat flow through that masonry wall, that's still allowing it to dry out.
So do you actually calculate that balance in that R value?
Yeah, I'd like to say we were super scientific about it. I don't think we're not that scientific about it. We really, we assess the waterproofing on the exterior of the building, and if we have concerns about it, then we'll be really rigorous about it. But if we have good bulk water management where we are, that's typically enough with relatively light R values.
One other question on that exterior wall. We've seen at least 2 projects presented where National Park Service limited the amount of insulation plus interior surface to 4 inches, such that they would be telling you that a room on the exterior wall, that wall can't move more than 4 inches in. Have you run into that also?
I have not worked on a National Park Service project, but I would say, just sort of tie it back to the EnerPHit standard, that would be one of those places where if that 4 inches didn't get you to the EnerPHit by component R value that you needed, then you would go to PHI and say, they're telling us we can't do that. And you could still, certify the building as long as you had the other components in line with certification criteria.
Thank you.
Sure.
Luke, how about you go next?
Thank you. And thank you, John. This is a great presentation.
Sure.
I wanted to ask about what just, I haven't dived into the EnerPHit standard as much. And so I wanted to ask about what really felt like an oddity in what you mentioned regarding the exterior versus the interior application of insulation. And so kind of following on Hank's question, I was always under the impression that you could get away with less continuous exterior insulation to achieve the same goal. And if you're applying it on the interior, you need more, or you need to be more strict about keeping it continuous. And yet the prescriptive element that you mentioned gave quite a reduction in the insulation value for interior application. What was that?
I think you're right. But I think the reduced requirements for interior insulation are an acknowledgement of what Hank was talking about, which is that like we can do our buildings harm by really going too far with the insulation from the inside. And so we are better off. We're going to build a better building by doing less insulation from the interior, and we'll have. I think that's what PHI is getting at there. They're trying to acknowledge the fact that interior insulation is hard and risky, and it's less risky if we add less.
Mitigate the risk.
Yeah.
Yeah. Okay. Thank you.
Sure.
So there's a great question in here following up on the cost one from earlier that John, I'll have you address, but then we can open it up if others want to address this one as well, because it's a very, it's on point for everything we're concerned about this time, and why we're focusing on retrofits throughout this every presentation this year so far. Is what's the vision to achieve passive house for all if retrofits are still costly? How do we get that down to the point where we can have passive house retrofits for all?
That's an excellent question. And I think, in this case, we could switch from trying to we're doing an EnerPHit by energy demand retrofit of that wood framed building. And we could target the EnerPHit by building component method instead. And we could reduce the amount of exterior insulation that's required on that building. And we could probably get it in, into better budget numbers. That would be one approach. I think that's one of the nice things about this sort of flexibility of the two certification paths for EnerPHit, is that you can kind of take the lane that you need to and get the building that you need by choosing one or the other of those pathways. Other than that, I think we need more of the products that we like at better cost, and that just means we need more of the products that we like, right? That means that we need more competition in like the wood fiber insulation market, and we need more local production of some of the things that we're ordering from far away.
I would add a
Please.
volunteer throw in there. The step-by-step method as well, so that you're paying for the retrofit as things are aging out, and you're planning that efficiency into the lifetime of the building. So it's not a one-time thing. And that's going to be true for most people in most situations. I mean, what we're seeing with a lot of the retrofit projects are relatively well-off people buying homes and gutting them. And that's not for all by any stretch of the imagination. But that step-by-step process certainly is for all. Everybody's going to do it. And what I would say is, and I think that you have the quote at the end, John, which I think sets off kind of conceptually where things stand, is that we're going to retrofit and replace items one by one over time in a planned way to get to a low energy, high performance passive house type of state. But as we go, it's really important to do the best thing that we can do each step of the way. So we're not putting in windows that are of less quality because the wall is of less performance. So we're not taking the argument that we want to just improve slightly on what's there, because at the end of the day, once you've renovated everything, you're not much better than where you started. So we want to maintain the high quality. And I think the other, and then I'll maybe to Hank, is it does cost more. I think it's manageable. Scaling it is a huge aspect of this, and just getting people familiar. I think what we've seen in Passive House in general is there's a big fear factor, and there's a learning curve. But once people get comfortable and we can scale, there needs to be more investment, and just as a society that we're putting the money into quality building rather than just mediocre buildings and spending it on the energy. Yeah, I had another point, but my cat has made me forget it. So I'll leave it there for the moment.
Hank, you want to jump in?
Yeah, I'm wondering whether you have any knowledge of, if not experience with, how the experiments in Europe is going with Energy Sprong and its ability to meet EnerPHit standards. Is it kind of a given that they'll do Energy Sprong projects that will clearly meet this criteria?
I think somebody on the call is probably going to be able to address this better than I can, but I would say simply yes, I think. But I think lots of folks know about that program probably more than I do. So I'd encourage somebody else to jump in.
Yeah, I would say two quick things about it. I don't think that Energy Sprung is getting quite down there, although it's quite good and it's admirable and it's changing the market in a bunch of ways. PHI, to address that issue, is kind of launching. They've done a beta test research over the past couple of years on their version of Energy Sprung called EnerPHit. And there's a bunch of beacon projects that they've done for a research study in a bunch of locales in Europe. And we actually have a presentation, a session from PHI on EnerPHit and that program and the results of that, with folks speaking from some of those projects. So they're trying to bring that together and incorporate that into the approach.
Excellent. We had a question here on how the EnerPHit standard relates to PHIAS and if there's a corresponding standard there. Quickly, I'll mention that we did have a presentation earlier this year from a representative from PHIAS talking about their new Revive program that does get a little bit at the retrofits of buildings. It's meant to target those. So you can find that on our website if you'd like to kind of see that presentation again. But John, I'll let you jump in if there's anything you'd like to say about how this relates to PHIAS process or doesn't.
Yeah, no, that was a great presentation. So if in your free time, definitely check that out. I think there's definitely a desire, as far as I understand, from the PHIAS side to have a retrofit standard. I think it's still a bit in its infancy, and sort of is pretty much on a case by case basis in terms of the way that the standard is adjusted for a renovation project. So it is effectively, as far as I understand it, and I could be a little bit wrong on this, but effectively it is the PHIAS standard with some allocations made for problematic thermal bridging or problematic solar exposure, but it's not codified as a certain set of certification criteria that one could apply. So it's a thing that you need to work with your certifier on to understand. One of the nice things about having the EnerPHit standard is that as a consultant, I can look at the project documentation or the standard documentation, and I can then advise my clients without having to first go and sign up with PHIAS, sign up with the certifier and do the whole process. I can lead them on the path towards the certification without having to have an exception made on my case. So I think PHIAS is on the way to developing that standard, but it's just not quite there.
Yeah, and I think that echoes some of the things they mentioned in that presentation. I referenced that this is in development and they're working on it. So it's nice that EnerPHit is well, it exists, it's been used, and it's
Yeah.
known.
And I think, unfortunately for the folks at PHS who are working on this, is they're developing this, they have been for a while, but they're developing it in 2022, whereas the PHI's version was developed in 2010. And there's just a whole lot more to consider now when we develop a standard. In the back of our head, even though these are, this is all about operational energy, the Passive House standard is about operational energy. Can't help but think about carbon, and you can't help but think about embodied energy, and there's all kinds of other things that are probably feeding into that decision making that's that weren't necessarily top of mind in 2010.
Hank, you can jump in again.
Yeah, this is more of a suggestion for all of us, I think. We've touched upon the idea that we know that National Park Service projects that are extremely important because of the funding that comes with them. So many projects cannot get done without those historic tax credits that have to go through the National Park Service certification program. And we know it's a struggle. We were talking earlier this afternoon at our board meeting about particularly windows, which can be very challenging. And I think that we should try to come together as a team of people to document whenever we get good news from National Park Service, like we have in the Moran Square project in Fitchburg, where they managed to get a window certified that most people said could never be certified by National Park Service. Some people have managed to get around the 4-inch on the interior issue. And I think we should start trying to document that, because we have another level of historic rehabs that's even, in some regards, more difficult. National Park Service, you're dealing with professionals who really understand the issue. They may not understand your point of view, but they understand the issue well. And on the other hand, you have many projects, especially in a state like Massachusetts, where these decisions are made by local historic preservation boards. They don't necessarily have that expertise. And I think that we could benefit by coming up with a data bank of favorable National Park Service decisions that could be shared with local historic groups to help them understand that maybe they need to be a little more flexible, like the feds. So just an idea. I think we should try to see if we can put together some type of data bank of those type of favorable NPS decisions.
That's a great idea. Where do you think that would live, Hank? Where's the appropriate place where would I go to find that, do you think?
Yeah, where would you go to find it?
I mean, I'd use the internet, so I just find it probably, but.
We're going to have Aaron set it up.
We had a similar idea that I think died on the vine here in New York, because often we have to get like a variance from the building department for this or that. And definitely from historic preservation, we were getting, had to get windows approved for different projects. And it was for a while there, it was on a per project basis, and you'd have to like go in front of the council and, get a note from the governor and your mom. But eventually, that became a little bit simplified. But the idea was to sort of have this sort of databases, place where we could all go and find that time when somebody said that we could do something, and then you could show it to the next person and be like, look, they said we could do the thing. And then, just having somebody sort of in your court that way, like can help to convince that next person to allow you to do whatever it is you're trying to do.
Right.
So, having a database or some place to go for these kinds of determinations would make a lot of sense, I think. I'm just not sure where it is.
Yeah, we have to figure that out, but I think we might try to do something here at Passive House Mass as a starting point, because we do have some of these kind of projects that have come up. So we should keep this conversation going, but we might start to give it a try.
Mm-hmm.
Great project, great presentation. Thank you, John.
Thanks, Hank. Yeah.
On this topic of resources, another thing we've been talking about is what you mentioned, the step-by-step approach to take with renovation. So I'm curious if John or Ken, who you discussed this as well, if you guys know of any resources for homeowners to help them manage this process, work on high performance retrofits over many years, over a long timeline. For example, how to be their own GC in this case, or how to prioritize which renovations to do first. Anything that you know of there to help folks out?
I think there's some good graphic guides from the Building Energy Exchange. I don't know if you folks are familiar with that resource, BEEX, Building Energy Exchange. And they have some great just overall passive house guidebooks and things like that. But they have some specifically on this sort of step-by-step idea, and help you kind of game out which thing to do first, and which things like a little hard to do first. So I think that's a good resource. And then Passipedia, which is like the information clearinghouse for Passive House Institute. There's some good step-by-step renovation resources there as well.
And on a practical kind of standpoint, if you are a homeowner who wants to eventually retrofit to the Passive House standard, and you're going to do this step-by-step approach, when would you suggest actually bringing in like a Passive House consultant or certifier? At what point do you actually engage with Passive House itself? Yeah,
I mean, I think to me, you don't know what you're doing until you've got the energy model to look at. And so I think from very early on, like, shortly after you have the idea to do it, you hire your Passive House consultant. Because I mean, and we see it all the time with projects that come to our office, is that people sometimes even overdo because they know, oh, we're going to do Passive House, and they'll design an R120 roof and be like, this is what we're going for, and you can kind of help early on, bring things into the realm of the possible and the sane, and get the project on the right track, so that then in that there's no wasted energy modeling ever. That first energy model you build for a project is the same energy model with updates that goes all the way through certification. So you might as well get that person on board early.
I would just offer to throw out there that before you actually need to do anything, because also see where people get in a pinch and they have to replace it, and all of a sudden all the good intentions go out the window because something has to get done. So to get ahead of the curve, which is a really tough thing to do, but and be able to make that plan rationally rather than just reacting to things breaking.
Yeah, I think somebody said once that the reason heat pump hot water heaters look like they do is because something like 95% of water heaters are replaced in an emergency. Like, your water heater broke down, and so I got to go drive to the place, and I have to get a water heater, and I got to put it right where the old one was. And so that's why heat pump water heaters are like that. Like, there are better systems out there, but they're not one you can do on a weekend with your cousin, So.
Well, I think that was a great answer to that question. Thank you so much. That's what I have from the chat room here. I'll give a little pause here to see if anybody in the room has any more questions. You can raise your hand, but otherwise, John, I want to thank you so much for putting this presentation together. And I do, and Ken, I'll let you say a few things here as well. But again, thank you, John. This presentation is going to be recorded and live on our website, phmass.org, so you can find it there, as well as all those past presentations that we've had. Ken, I'll let you say any last things here as well.
Yeah, I was actually just going to go back to the questions, but
yes, if there's
sorry,
I think that I got, if there was one in there I missed here. I've been scrolling through here, but feel free.
No, well, I was just going to mention in terms of the retrofits and cost and states investing in it and whatnot. I mean, you see more and more interest, obviously, and in New York with the Retrofit New York program, they're looking to invest in scaling the energy sprung type of model for multifamily and making it affordable at scale. Unfortunately, the single family house, both in new construction and in retrofit, is the hardest type of passive house you could build. But I think we'll see more of that. And hopefully the Retrofit New York has been an incredibly painful process, at least witnessing it from the outside. Hopefully that will start to bear fruit soon.
I know there's been folks on this call right now who have been working to, get Massachusetts to incentivize retrofits as well, which is a work in progress.
Yeah. Yeah. Oh, I remember what the cat stopped me from remembering was I was going to throw it at Heather Clark, because she did a great presentation early in the year too, I believe, and was talking about the affordability and how to argue that. And maybe Emily Jones would be able to help as well from Litch and the programs that they're doing. So it's possible. We just really need to be intentional.
Yeah.
They're not all going to look like mini mansions.
I think that intention is important, and this goes back to what you and John answered for that other question: getting a consultant or verifier or certifier or whoever you need to involve early in the process. I know for a lot of people approaching this, that can seem daunting, as they don't want to pay that money right away to do this, but it's actually gonna make things cheaper in the long run to start this as early as you can. So that's all I have here, folks. I'm looking forward to seeing whoever can make it in person next month. In person. But once again, we're gonna work on making it a hybrid event, so folks can join from their home for our meeting. So you can join on the second Tuesday of June, and then of course seeing folks in person at the Passive House conference in District Hall.
Yeah.
Great, thank you. Great
That's good.
presentation.
Thanks, everybody.
Thank
It was
you.
fun.
Take care.
Have a good night.